And then we come up to our next speaker. Our next speaker is Emma. Emma is the Group Sustainability Manager for Gammon Construction Limited. She is responsible for advising on project-specific environmental issues as well as driving sustainability initiative. Her current focus is on the implementation of their responsible growth 25 by 25 sustainability strategy. She has 25 years of professional experience in Hong Kong, Shanghai, and also Ho Chi Minh City. Her background covers environmental consulting, project management, risk management, facilitation, business development, sustainable urban planning, tourism planning, and green building. Oh, very comprehensive, Emma. Emma is also supporting a lot of association on sustainability aspect. Then I pass the mic to Emma. Welcome, Emma.
Thank you so much, Felix, and thank you very much for inviting me along to share our journey and our ambitions. I'm gonna just share my screen. Can you see that okay?
Yeah, okay, we see it.
Great, thanks. So yes, I'm going to talk in more detail about construction, following on from the previous presentation, which sounded excellent actually. And so I'll talk about cutting carbon in construction. Let's see if we can get this working. Here we go. So I think there's over 500 people on this webinar, which is fantastic. But I'm not sure how many of you are familiar with Gammon. We are a multi-service contractor working in all different fields. We have a over 60-year history in Hong Kong, one of the largest contractors, and very happy to have worked on over 160 green buildings. Our sustainability strategy, Felix mentioned, we call it Responsible Growth 25 by 25. We've got around 20 or so targets and some headline targets there. And the one that is of relevance, I think, is the carbon intensity target, a reduction of 25% by 2025. Carbon intensity, I think it's interesting that, you know, we set this a couple of years ago or 3 years ago. Really, we need to be looking at absolute carbon emissions now, and that's what we're doing now. We've been reporting voluntarily since 2003, and we do a lot of engagement with our stakeholders, whether it's internal through our Sustainability Month or external through, we've had conferences and webinar series ourselves before. So let's get on to the meaty part, the climate change mitigation, which is the topic of the webinar today. What does it mean for us in the construction sector? I think it's, I'm sure many of you have seen these climate stripes before, but what is of most interest, I think, is that the construction sector is one of the industries that really is directly impacted by global warming. These extreme temperature changes and also, or temperature rises, also extreme weather events. It's not just globally, it's also locally as well. You can see these are the stripes for Guangdong. And, you know, we've got increased heat stroke risk for our workers and our staff on site. So it is really imperative that we take action. And I'm going to talk about two parts of the carbon equation. One is the embodied carbon, which is all the energy and the carbon wrapped up in the materials through raw material extraction, manufacturing, processing. And the other side is the operational carbon, which is probably more familiar for most of you, is the you know, the energy being consumed in buildings or indeed within infrastructure. And the thinking now is very much about whole life carbon. The outer grey circle you can see there is the embodied carbon piece. And the issue is that, you know, traditionally the focus has been a lot on operational carbon, but the grid electricity is decarbonising. and the embodied carbon part is becoming much more important and more of a challenge to decarbonize. From the construction aspect, we call the first part that we're focusing on in terms of mitigation the upfront carbon, and that is two aspects. Then we've got if my mouse will work, come along, here we go. We've got the materials embodied carbon, as I mentioned, and the carbon from construction activities. So this is what we're actually doing on site and the energy that we're using in the transport and also the activities on the projects. A little bit of context then is the World Green Building Council vision for carbon reduction, and they have two milestones. I'll make these a bit bigger. 2030, they expect to see 40% less embodied carbon with significant upfront carbon reductions, and all new buildings must be net zero operational carbon. That's a real challenge for Hong Kong with our very high-rise, high-density development, subtropical climate, and reliance on air conditioning. So that's a real challenge. For 2050, everything should be net zero carbon, whether it's the embodied carbon or the operational carbon, and that in theory should be new and existing buildings, as well as infrastructure. And I think, there's a lot of discussion on green building operation, but we don't tend to talk too much about the infrastructure side. And from a construction perspective, the embodied carbon wrapped up in infrastructure, things like roads and highways, that's the majority of the carbon that we've got to try and mitigate. So certainly a challenge. So I'm going to talk about it in four aspects. So these are the key players, I'd say, the key groups of players in the construction sector, and that can influence that upfront carbon. I'll focus obviously more on the contractor because that's what we're doing, but I'll touch a little bit on the other areas. Starting with the project proponent then, this is the client, whether it's government, whether it's private sector, there's certainly a role that the client can play in terms of carbon mitigation. Sorry. And I think this graph is important because it highlights that the biggest opportunities for carbon reduction happen at the very beginning of the project. So at the planning and design stage, you get the greatest potential for carbon reduction. And some countries are setting targets for use during the design stage to try and push down the embodied carbon for projects, and to take a life cycle approach, whole life and embodied carbon thinking. We can't just look at the operational carbon anymore. And I think some of the clients are already doing this, is to integrate low carbon specifications into contract procurement, and to engage with the contractor during the early stages of the project, and even during design. The client can also set the design life, so a longer design life will ultimately reduce the embodied carbon of the overall project, and perhaps specify that the building should be flexible for adaptation, and it should be designed for disassembly so that you can get the maximum use out of the materials for recovery. So these are the roles that the proponent can play. From a designer's perspective, this is where there's the opportunity for optimizing the design to reduce the amount of materials that are used, and to specify lower carbon materials. You can see here's a couple of pictures. These are void forms for concrete pours to reduce the amount of concrete used, or using, for example, the AAC blocks instead of concrete blocks in walls. And the lighter the structures are, the less foundations we'll need, and this will have a major impact because diesel used in foundations is one of our biggest challenges to reduce the carbon of. Lower part of the picture there, you can see that the opportunities for timber use, mass engineered timber, that would be fantastic to see in Hong Kong. not an easy thing to bring to Hong Kong, but we hope to see this in the future. And then on to us as the contractor then. What is our role in all of this climate change mitigation, and what have we been doing? So our carbon reduction progress so far has been pretty good. We've been reducing our carbon intensity over the years, but also our absolute carbon has been reducing. And we're in line or ahead of the targets that were set by the Hong Kong Construction Association a number of years ago. But you know, this is really focusing on scope 1 and 2 emissions. And what does that look like for us? Then I mentioned the diesel, the dark blue there, diesel being a big issue for us, doing foundations, doing heavy engineering, and traditionally, you know, using generators on site, even for cranes. The plant and equipment using diesel is the biggest challenge for us. We're only using about a quarter is electricity to power our sites. But we know that scope 1 and 2 is not sufficient. We've got to be looking at scope 3, and our starting point is really where we can directly control that scope 3 emissions. So that includes things like waste and water use, but importantly for us, it's the temporary work. So these are the works that we would need to do in order to build the project. We will put up things like formwork or steel struts in an excavation, and then we'll take those away afterwards. And those are the things that we can influence. Then you've got the permanent works, so temporary works. Permanent works is the finished asset, whatever we're building. So it's the embodied carbon for the temporary works that we can potentially more directly control, and that's where we've got to focus our energy. But the situation is that around 90% of the upfront carbon is in the embodied carbon in the materials, in the permanent works materials. Our part really that we can directly control is only around 10%. So a big challenge for us all to try and tackle that. When it comes to delivering the projects on site for the construction stage, then what do we need to do? Well, we need to work and collaborate both with our clients, project proponents, as well as the designers upstream, and we need to influence our supply chain downstream. Directly, we need to make sure we're reducing our scope 1 and 2 emissions, so using less or lower carbon energy sources, and then delivering efficiently. So the primary objectives are things like using the technology, using digital twins, digitally rehearsing the delivery of projects, the building of projects, and off-site construction. Those two things are going to give us a big advantage in terms of making sure that we're not doing rework, making sure that designs are all coordinated, and we're producing them efficiently off-site in factories where we can control the environmental management much more easily. Also, the construction methods. So that was the temporary works I mentioned, and I'll give you some examples of those. Waste and water management, very important, and finally, with our off-site partner factories, is making sure that they are managing their environmental impacts and using low carbon energy, these kinds of things. So one of our big areas of temporary works, embodied carbon, is the steel work that we will use in excavation. So you can see here examples of the Lyric Theatre and also Central Kowloon Route. These massive struts, massive steel struts, a huge amount of embodied carbon wrapped up in those. So we are reusing these as much as possible. We design them in a way that allows them to be modular and reused, and reusing them on several different projects. We want to try and keep reusing them for as long as possible. So this is a major opportunity for us. Here's another example of that structural steel temporary works. All of these red towers, the modular steel towers, are used to support a big steel truss that's going across the top of the building here at M+, actually. And those have been used on several different projects. You can imagine it's a challenge to store all of these things, but this is what we need to try and work towards. We can do alternative design for foundations, and we use the CIC, the Construction Industry Council's carbon assessment tool to optimize things like the concrete mixes. So we use a higher strength concrete and reduce the amount of reinforcement bars that we're using. And that can give us carbon reductions for embodied carbon. And another example of how we've changed the method for construction. Here we're doing a bridge, and in order to build those foundations, we've had to excavate some of the marine sediment. And the idea was that marine sediment would have been disposed of in a marine site. We've chosen to make sure we stabilize and reuse that material directly on site. And not only to stabilize it, we also are reducing the amount of cement that's needed in order to do that. So yeah, nearly 2,000 tons of embodied carbon emissions saved there to change the treatment method and trial lower cement mixes. Hope I'm not getting too technical. We still rely on timber, particularly for formwork when it's an untypical construction, things like a podium for a high-rise residential building. And when we do use this, we make sure that it is sustainably certified. Obviously, this also can reduce the carbon footprint. And I mentioned this carbon assessment tool. So this is a free tool that designers can use, that contractors can use, to assess different design options when it comes to the materials. And this is all updated with the most relevant embodied carbon emission factors for different types of materials used in the construction sector. And it also allows contractors to record their upfront carbon emissions, the construction part of that upfront carbon. So a great tool there. We actually helped advise on that one. And then we come to the BIM and offsite, so the building information modeling, breaking things down and coordinating them for shop drawings. You can see for the factories. This is a typical example of what we've been seeing in the industry, these modular integrated construction units. Unfortunately, these are at Penny's Bay, an unfortunate necessity. We have, but in terms of offsite construction, there's lots of different methods of doing this. We started off, I think, mainly with the E&M module. So this is the Murray Hotel. And we've been using these kinds of things in data centers, precast slabs in the project actually that's shown here for the science park. There could be bathroom pods. We haven't really seen these being brought into Hong Kong very much yet, but bathroom pods, kitchen pods, toilets we are doing. And then, yeah, the full-blown modular MIC projects. And they're going to have a big improvement on things like the energy used on site, waste and traffic movements. And even once we include the factory emissions as well, we're still going to see reductions. And BIM also saving waste. There's not a huge amount of research that's out there, but based on our own experience at Penny's Bay, we compared this construction against other residential projects that we've done. Not very typical, but anyway, even when we were using diesel, there was no electricity on this site. We used diesel for the project and we got nearly 40% carbon intensity savings, good waste savings, yeah, good water as well. So real opportunities there in terms of using MIC. And then moving on to the energy part, the scope 1 and scope 2, we've been using B5 biodiesel for a number of years on all of our plant and equipment. But there are limitations. There are a new generation of biofuels, which we will be looking at. Some challenges there, but we think it's probably going to have to be part of the solution in the interim. And overall, there are going to be a blend of solutions needed. And this is our sort of vision. I'll take you through some of these aspects that we've already started doing in some areas. So the first thing is the low carbon supply, and it's great to see the government committing to decarbonising this energy supply. So the more we can use in terms of electricity, or the more we can transition to electricity, the better. That then enables us to connect to the grid and use things like the battery energy storage systems. I think Sino mentioned this earlier as well. So we were one of the pioneers for this, and we helped Amped Energy to develop their solution. And this can then be used particularly for the plant that has very intermittent power demand. We can also use that electricity for charging EVs. We've started using EVs on projects, and we have more, well, some smaller things like the pickups, sorry, the forklifts, EV forklifts, but in future, we're going to expect to see smaller plant becoming electric. Here's the Amped Entertainer. I think we've got about 7 of these in operation on projects, particularly for tower cranes. So you get really good reductions. I think Sino mentioned 85%. So yeah, good reductions in terms of carbon. And why do we want to use the electricity supply? As I mentioned, we know the electricity supply is decarbonising. And for us, there are other benefits, particularly for health. We know that diesel is not particularly nice, and we've got noise and risk issues as well. So all of these things point towards electrification from the beginning. But the challenge is that at the moment, we typically wait for around 6 months before we get power connection. Some of our clients have applied for it early, but in most cases, there's not normally sufficient power on site. And so we can't adopt that electric plant. The government has also recognised this, and they have now issued a circular about government works projects having to have a small supply at the beginning, but what about the private sector? And so we've engaged with the Business Environment Council to develop something called the Power Up Coalition, to try and encourage that early electrification of construction sites. And we've developed a forecasting tool for helping the developers and their teams to be able to do that early application. So we're moving the application much earlier in the project, which means that once we start construction, we have electricity available on site. And in future, that's going to allow us to bring in some of the heavier plant and get sufficient power as it starts to convert to electric power. But I don't think it's only going to be electricity. We're also, obviously, we're trying to use some renewable energy on our projects, and I'll give you an example of that. But in future, we're going to have a mix of solutions, mobile plant on charge, some non-fossil fuel foundations equipment. Hydrogen is likely to be in the mix, particularly for heavy vehicles that are used in bringing in MIC units or removing waste, and then off-site construction, as we've mentioned before, is already the way forward. Here's an example of a project where we've got renewables being used on site at Seychelles Road. Allows us to take advantage of that feed-in tariff, which is generously provided by the power companies. And then moving to a corporate level, we're also using these solar PV systems on our own facilities. We've heard quite a lot about net zero targets and science-based targets. We're not quite there yet. We are committed to a 50% reduction by 2035 of our scope 1 and 2, and alignment with the government ambition for climate neutrality by 2050. For our scope 3 emissions, we will be doing developing a detailed climate action plan, and we hope to commit to the Science Based Targets Initiative this year. We're also going through the TCFD recommendations, and we'll be including that in our sustainability report this year, which should be out in a couple of months. So finally, I think I'm running out of time, the role of suppliers and manufacturers, and it is very much a journey for these materials. You know, we're so dependent on concrete and steel. Hopefully future we'll see more timber coming in, but it is a real challenge. We're one of those suppliers because we do produce concrete mixes. We have several batching plants, and we've taken the initiative to get CIC green product certifications. Over 90% of them are gold or platinum level, and that gives us pretty good up to 30% carbon reductions. And we're looking this year at bringing in some carbon curing technology, and also hopefully the use of GGBS as a cement replacement. The steel industry is closely looking at this. They know that they will need to decarbonize, and we've just got to be aware that you know, there could be cost implications of that, and increasing demand for lower carbon steel. So the design efficiency is very important. And then in conclusion, what can we do right now? Here's a quick summary. From a proponent perspective, we love to see more life cycle carbon assessment and low carbon specifications, and that will really help to drive down embodied carbon from the outset. From the designer and from the government departments supporting those designs, we'd love to see lean design, and to make sure that the off-site construction is being designed in during the design stage and programmed. For us as a contractor, we've got to deliver efficiently. We've got to reduce our energy use, and we've got to deliver as much as possible off-site. And finally, suppliers and their role in terms of producing lower carbon intensity products. And as a contractor, we've got to work with those suppliers. And I think that's the story, is that everybody needs to be working together to try and reduce carbon emissions and to mitigate climate change. So thank you very much indeed. That's it from me, and I'll hand back to Felix.
Yeah, thank you, Emma. Thank you for your presentation, which you have specified that the responsibility of different stakeholders are very important in reducing climate change. Although you are running out of time, we are running out of time. But there are some questions from the audience. Maybe I would like you to try to answer. The first question is, if the embodied carbon is calm, what are your strategy to achieve carbon zero?
It is going to be a journey with our suppliers, and there is going to be a certain reliance on the suppliers to be producing these lower carbon materials. But we have to look at it from all angles. So I think the energy side, you know, the picture is almost clearer and more certain on the energy than it is on the embodied carbon from materials. So I've forgotten what the question is now, Felix. I'm going off topic.
Oh, okay. Yeah. Anyway, and I think there's a related question is how you monitor the carbon reduction operation of your subcontractor.
So it is unfortunately it is bundled up as the whole site. So we will track all of the energy that's used on the project. It's not apportioned to different subcontractors, because as you can imagine, we've got subcontractors, many different subcontractors working at the same time. So it's very difficult to identify which contractor is using which energy. From a we tend to use our own plant and equipment, and so we will understand our own diesel use. For subcontractors, if they are using their own plant and equipment and supplying their own fuel, we're not tracking that yet, but that is something that we're going to be working on, because we do need to understand their carbon footprint as well as our own.
Thank you. Something have to be done step by step.
Yeah, that's for sure.
Yeah, there's some kind of time to educate the supplier to reduce the carbon. And the another question is, will you please indicate the percentage of scope 1, 2, and 3 carbon emission of your company? Do you have any idea?
Yeah, I showed it
Yeah, I think you showed it, yeah. It's fine. I think your PowerPoint have showed it, is it?
Yeah, it's so you can see it afterwards, can't you? You've got the or you can see it in our sustainability report as well.
Okay, that's good.
Then
there is another follow-up. What is your midterm, say 2030, and the long term 2050? Your target to reduce scope 3 emission. Scope 3 emission.
So the 2035 for scope 3 emissions will base on science-based targets. So it'll probably be around 50% scope 3 reductions. It will depend what the science-based targets initiative and our consultant say to us, but we'll probably have to be increasing with our clients, increasing the quantity of low carbon steel, maintain the reductions in low carbon concrete. But yeah, it's probably going to be about 50%, I imagine.
Okay. There's a lot of questions for you. What is the low carbon concrete mix in your site?
Okay, so the low carbon concrete mixes are a combination of lower carbon cement. So we buy our cement from Japan, and even once you include the transport from Japan, the carbon emission is still lower. They have an efficient manufacturing process. They use waste heat as part, like the waste to energy incineration is part of their cement manufacturing process, and they do some re-injection of carbon dioxide as well into the process. And then, so that's the cement. The cement is lower carbon to begin with, and then we use it. We have a range of design approaches for the mixes, which includes additives. We have our own chiller, because sometimes we have to have temperature controlled concrete. So instead of using ice, we have our own high efficiency chiller, which produces chilled water. So there's a range of and the other one, of course, is replacing the cement. So we use some cementitious replacement like PFA, for example, the pulverized fuel ash. That is another way of reducing the carbon footprint. So a range of different ways of reducing carbon in our concrete mixes.
But having low carbon cement in Hong Kong is not a simple solution.
No, I think the local cement manufacturers are looking at solutions. At the moment, as I say, our cement comes from Japan. Okay. But I think we need to try to replace our cement as much as possible. But ultimately, there's going to need to be carbon capture and storage in the cement manufacture process.
Yeah, hopefully. Well, somehow nowadays it seems that we have to rely on some technology to help us. Yeah, or some breakthrough. Yeah. Okay.
I mentioned the carbon curing technology that we're going to be bringing in this year. This is something called Carbon Cure. It does waste carbon dioxide injection into the batching process. So you can get about another further 5% cement reduction from that. So this is going to be new this year.
Okay. And we come up with the last question from the audience. Is there any ballpark figure on the cost increase due to the implementation of all those kind of green construction measures on site?
It depends when.
Okay.
I think in a few years' time it might become more expensive. No, there are ways to keep the cost down. We're a little bit lucky in the fact that we are a big contractor with you know, good economies of scale in terms of buying power. But I give you the example of the structural steel struts that we use. That's no cost. So once we bought them once and we continue to use them, then we're starting to save money. So some of the methods are going to be more expensive and others are going to be cheaper. Electricity instead of diesel. If we're using electricity for a tower crane, that's going to be cheaper than it is to be using diesel. So yeah, I have no idea if there is actually at the end of the day a real cost increase, but I can imagine, for example, the steel in permanent works, I think we'll see an increasing demand for the lower carbon steel. So you might see a bit of an increase in the cost initially until the whole market works out. I mean, that steel is something that's traded at a global commodity level. So the price will fluctuate. If you manage to get buy a big, you know, amount of steel at the right price, you won't have an increase in that cost. So yeah, there's many different parts to the cost equation.
And somehow we have to look at a so-called life cycle costing, look at the longer term. In fact, a lot of the green measure can save the money.
Yes, absolutely, yeah.
Yes, thank you, Emma. Thank you for your time. Yeah, for your very comprehensive sharing. Yeah, and all those. Yeah, thank you very much. Thank you.
Thanks. Bye.